number 9, we want to graph, the graph of the piecewise function is shown. We want to write the equation. So we're going backwards now. They've been giving us the equation, and then we've graphed a few. Now they're giving us the graph, and we want to write the equation. So there's a line going this way, and then a line going this way. So there's 2 ways that you can do this. One is you can do slope formula to find the slope. So you can do m equals y2 minus y1 over x2 minus x1 and find the slope. And then once you do that, you can use point slope form of equation. Y minus y1, one of those points, equals m times x minus x1. And then you can convert that to be slope-intercept form. Y equals mx plus b. In my case, I'm just going to start with slope-intercept form. And the reason we can do that is because we can see our intercept, our y-intercept. This is the y-axis. Both of those lines go to the point 0, 0. So this is going to restrict our equation. Since your y-intercept is 0, y equals mx plus 0. So when you add 0, it doesn't change anything. So our equations are going to be simply y equals mx, which we just need to find the slope. And we can find our slope by counting rise over run. How far do we rise or fall, go up or down? And then how far do we go left or right? Okay, so we're going to start with this point, -3, +2, and we're going to go to the right. We're going left to right to this point. So to get from here to here, we have to go down 2. So we went down 2, that represents a -2. And then we go right 1, 2, 3. So we went right 3. So your slope for that first line is -2 over 3. So y equals -2 over 3. And then you add your x at the back, and this is one of those equations. Now, what are its limitations? Where is this function defined? Because it does not span the whole line. Well, in the x direction, it starts, the furthest it goes is -3, and it goes all the way over to 0. So its restrictions are -3 less than or equal to x less than or equal to 0. So these are its restrictions. That's the first part. We're going to do the same thing for the second part and then plug it in. But let's first insert this. So f of x is -2 divided by 3. And then add the x at the back. And then that says if we are between -3 and 0, because that was our restriction. Okay, so that's the first part. And now the second part is this line. We can do the same thing, okay, because the y-intercept is 0. We don't actually have to go through that full-blown finding the slope and then doing here, because the slope is easy to count from the graph here. So y equals, let's find this slope. So going left to right, we have to go rise up 2 and right 1. So rise over 1 this time is 2 over 1, and 2 over 1 will reduce, so we have y equals just 2x, okay? And our restrictions, this graph is between the x values of 0 and goes over to an x value of 1, so it only goes the distance of 1. So this is between 0 less than or equal to x less than or equal to 1. Always go left to right. It's always less than symbols. And because those points are included, we do less than or equal to. Well, actually, this one says less than because we can't include 0 in both graphs. So since this one says less than, we're going to get rid of the 0 here. So get rid of the equal to part there. So that will be 2x if we are between 0 and 1. Now, just to show you, I do want to show you that we can and we are able to graph this function in the graphing calculator. So I'm going to go to y equal, not second, y equal. I'm going to clear this out. And first I'm going to show you the full-blown graph equation. So first we're going to do, and I'm going to do it in parentheses because that's going to save me some time. Whenever you do piecewise and you restrict the domain, you want to put it in parentheses. So I'm going to open parentheses. I got to type it on this calculator, I forgot. Open parentheses. We're going to do a negative 2 divided by 3 and then x. Actually, I don't like that. Let me delete. I want the x to be on the top. Second, insert x. Okay. Then close. X doesn't on the bottom, it should be on the top. So this is the first equation. The second equation was just 2x. So in parentheses, 2x. Close. Now first I'm going to graph and show you the whole thing. So that's one line. It spans the whole graph. That's the other line. Now I'm going to restrict it. So I'm going to go back to y equal. This first graph was restricted between negative 3 and 0. So the way you do that is you do divided by, and then open parentheses, and we're going to do negative 3, and then we're going to do math, or actually second math, and we get these logic symbols. So we're going to do number 6. So it gets the less than equal to, then we're going to put x, and then second math, and then number 6 again, less than or equal to 0. It may do it this way. We may have to do that and symbol whenever you have to do compound, but let's see. Let's graph and see if that first line gets restricted. Okay, so it goes second graph. It goes above 3. So let me go back and do that again. Y equal. So whenever you have a compound, we have to do both of them differently. So let me show you how that works. So we're going to do negative 3. Actually, I want to do it a different way. So I'm going to say all my x values are greater than negative 3. So I'm going to say x is second math. We're going to say greater than. We're not going to write it like it is. So number 4. All my x values are greater than negative 3. Okay. And then we have to do second test, and we have to use logic. Arrow over. We have to do and. And then we're going to say x second math is less than 0. 6 less than or equal to 0. So basically what we're doing is we're splitting up this compound inequality into 2 parts. We're between 3 and 0, but we're telling the calculator where x is. The x values are bigger than 3, greater than or equal to negative 3, and less than 0. So now if I do graph, it just traps it. So that's that part right there. Now I'm going to restrict the other one. So I'm going to go back to y equal. Go down to the second equation, go all the way to the back. We've got to do divided by. We're going to open parentheses. So we're going to do the same thing. We're going to say x is second math is greater than, so number 3, strictly greater than 0. And then second math, we have to do and, so go over to logic. Number 1. And x is second math. Option number 6, less than or equal to 1. And then close. And then we're going to graph. Now I'm going to zoom in a little bit. Zoom, option number 2. And then you see that better picture of your graph. So you can restrict it as well if you have a graphing calculator. You don't have to, but just something that I thought would be neat for you to learn how to do. So anyway, this is our second equation. We're going to check it, and it's good.